Alright, the next two sections actually are going to be about proving triangles similar. We're going to eventually have three ways to do that. We're just going to talk about one way to do that today. Okay, so this is kind of related to when we proved triangles congruent. Right? You remember, we have 5 ways to prove triangles congruent. Side, 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 angle, side, angle, 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 side, and hypotenuse, leg. We're going to have 3 ways to prove that triangles are similar. The first way that we're going to talk about today is called angle-angle similarity. If I can show that 2 angles in one triangle are congruent to 2 angles in another triangle, that is enough to prove that the triangles are similar. Right? So, if I look at this first example here, I'm told that angle B and angle E are congruent. I'm also told angles A and D are congruent. Just from that, that's enough to claim that these triangles are similar. Okay? All I have to show is that 2 pairs of angles are congruent. So, now I can claim triangle ABC is similar to triangle, and we need to make sure we're matching up corresponding parts. So A would match up with D, B would match up with E, and then C would match up with F. Okay, so all I need to show is that 2 pairs of angles are congruent. Then I can say that that means the triangles have to be similar. Okay. What's that? Only 2. Because one thing we talked about earlier in the year was if I know 2 angles are congruent, that automatically makes the third pair of angles congruent, right? Like if I know that both of these angles are 60 and both of these angles are 70, well then that means the third pair of angles would both have to be the same. They would both have to be 50. If I take 180 minus 60 minus 70, I get 50, and I get 50. So all we need is 2 pairs of angles. That's it. Okay. So if we look at this second example here, I've got angles B and E congruent. Right? I know that they are both 81 degrees. So I can say angle B is congruent to angle E. But then all I know is that F is 39 and A is 60. Well, we know how to get the third angle in each of these triangles. So if I solve for C in this first triangle, we would get 39. If we take 180 minus 60 minus 81, we would get 39. So then we can claim that angles C and F are congruent. And that's enough to claim that these triangles are similar. All we need is 2 pairs of angles. So then we can say triangle ABC is similar to triangle, and again, make sure we're matching up corresponding parts. So A would match up with D, B would match up with E, C would match up with F. Right, so in both of these examples, these 2 triangles ended up being similar. Right, but sometimes, and in some of these exercises down here, they won't. Right? We may get angles that are different in our triangles, which would prove that they're not similar. But all we need to show that they are similar is 2 pairs of congruent angles. Questions so far? Alright, so in the exercises down here, we sometimes are going to need to use properties that we've talked about in previous chapters, right? Especially if we're looking at a pair of parallel lines, we can think about things like alternate interior angles, corresponding angles. So like on number 2, for example, I'm told WB and YZ are parallel. remember these arrows mean they're parallel. So if I've got parallel lines, I can look for things like alternate interior angles. So in this example, I could say that angle W and angle Z are alternate interior angles. I could also say that these two angles here in the middle are vertical angles, so I know they would have to be the same. Then, that's enough to claim these two triangles are similar. Okay. Questions? All right, then let's take a couple of minutes and try these problems down here, seeing if we can get two pairs of angles congruent, and if we can, writing a similarity statement matches up corresponding pieces. Okay, so let's take 5 or 10 minutes here and try these.
Listen, Mr. Stern, I'm glad I prank called him.
Alright, take a look up here at some answers. Okay, now on these statements here, remember that you may have a slightly different statement that could still be correct. Okay, for example, in number 3 here, they name it triangle RTU. So we're looking at this big triangle and then the smaller triangle here. So another example of a correct answer could be TUR. We could call this one TUR and say that is similar. If we match up corresponding pieces, that would be TLS. Right? So just as long as you're matching up corresponding pieces, there are a few different correct answers for how you could write your similarity statements. Right? And the only one of these 6 that ended up not being similar was number 6, because we were not able to get 2 pairs of congruent angles. Questions on these? Okay, so we're going to go through today, talk about angle. Next week we'll talk about the other 2, and after we get through all 3 of them, then we'll look at some actual proofs. Okay, but we're going to talk about all 3 of them first before we actually write out like 2-column proofs. Okay. The other 2 are side, 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 and side, angle, side. Alright, so let's flip over to the back. On the back here, we are doing very similar things to what we did in the last section. Okay, we're going to just set up and solve proportions by missing pieces. So, in example 1 here, we are told that triangle KJL is similar to triangle MNL. We want to find x. So, we need to figure out which pieces correspond in this picture. Okay, so I'm solving for x. Does x correspond with 15 or 10? 15. Why?
Because the figures are on the same line.
The same diagonal.
So,
Well, not diagonal.
I mean, you're right. that it is 15,
Yes.
but reasoning maybe not so much. So what we want to think about, okay, in a figure like this, if we look at our similarity statement, x is side KL. KL matches up with L in the other statement. Okay, so if we are given a similarity statement, we want to use it to make sure we're matching up the correct corresponding sides. So the x and the 15 would be corresponding sides here. Then that leaves the 12 and the 10, would obviously be the other pair of corresponding sides here. Okay, so this is just like what we did in the last section, right? Just making sure we're matching up correct corresponding pieces. So cross multiply, we get 10x equals 180. Divide by 10, and x is 18. Now, example 2 is the same type of problem, just kind of in a word problem format. And this is actually one of the most practical applications of proportions, okay, something like this. So we say a 4-foot tall person casts a 3-foot shadow. At the same time, the telephone pole is casting a 9-foot shadow. We want to figure out how tall the telephone pole is. So this is a similar triangles problem. Right? However a shadow is cast, will create a similar triangle if we're talking about at the same time. So this is my x, the height of the telephone pole. To set up a proportion, we can match up corresponding sides and say x over 4 would equal 9 over 3. Cross multiply, get 3x equals 36, divide by 3, and x would be 12 feet. Okay, so since this is a story problem and we're given units, make sure to include the units in your answer. For just generic problems like this, we don't have units. But if we are given units, make sure you include the units in your answer. Right. So this is just like what we did in the last section, right? Questions. Now, I guess one thing, don't forget that it is always an option to reduce fractions before you start. So I could have made this x over 4 equals 3 over 1. Okay, you can always reduce the fraction before you start, and then if I cross multiply here, I get 1x equals 12. I'm done. All right. If you don't want to reduce the fractions, though, that's perfectly fine. You can solve it like this. Questions? All right, then let's take a minute here, and you guys try 1 and 2. Okay, we'll do number 3 together. If you feel confident, you can try number 3. Okay, but try numbers 1 and 2. What's up?
You know I hate that.
Stupid, dude. Stupid. Big goop. This is hard.
Oh, yeah.
Yep.
I thought it was 10 over 20.
No, because you have to do x over 13, so you have to do the same thing with the next one.
I thought it was
You
10
have
over
to
20.
apply the same one.
So since you wrote for your first one x over 13, you wrote big triangle over little triangle. You got to be consistent with big over little for the second fraction as well.
So it's 10x. You shut your face. Who? Good. What? It's 20 times 13. That's a big number.
I'm debating it.
Why did you do 2 over 1? Why?
So far, it's the same thing.
But it says 260.
Would you do 13 times 20?
Yeah.
13 times 20.
260 divided by 10. What's 260 divided by 10? Is that what you got? Ah, dude. I'm about to smack that shit.
I got X equals 46.
Like shit.
Oh, no, it's a different problem. Yeah, 6 over 6. This is the one that was 2. I put in the wrong answer, so I have to go back and manually grade that one. So I put it as 5 over 2 instead of 4 over 2.
Wait. It said I know. I put 1.
That's your catch.
Was it number 3? Then that's the one that I entered the answer in incorrectly, so I have to go back and manually grade that one.
I didn't know if I was that's his first answer.
Either of those will be correct answers.
This one you have to do x over 33.6, right?
Yep.
But if you go this way too, it's 23, but there's nothing.
You're right. So we wouldn't be able to use that pair of sides. We'd have to use the other pair that we already
30 over 6.
What, Italian? Yeah.
Well, the first one you can create, I did work on both. Well, I'm gonna force you to watch them. See, look.
Would you get a fraction for that? That's your fraction.
That I didn't
Alright.
for any of the other
Did we get 26 for the first one?
Yeah.
And 19.3 for the second one? Any questions? Alright. Let's take a look at number 3 together. So we talked about an example like this yesterday where we have a triangle inside of a triangle. Whenever we have a situation like that, we want to draw the 2 triangles separately. Right? So my little triangle is LPM, this triangle here. So if I draw that triangle and label its sides, I can see that LM is X, PM is 16, and then LP is 7.2, so I'm given all 3 sides. But then if I draw my larger triangle, this whole thing, so let me sketch that separately over here. That's triangle KVM. So now, what's the entire length of side VM? Right? I would add the 8 plus the 16 to get the entire length of VM is 24. What about the entire length of KM? So we don't know part of it, but how could I still write this? Not 9x plus x. Yeah, 9 plus x. Right? So I can write the entire length of KM as 9 plus x. Okay? So once I have my two triangles drawn like this, and whenever we're doing the big one, to get the total side lengths, we're just adding up pieces. Right? So the length of this side is 9 plus x, that is 24. Now we can match up corresponding sides. So this 7.2, I don't know anything about KB, so I'm just going to ignore that one. Right? So if I match up corresponding sides now, I would have x over 9 plus x. These two sides would match up. And then that would, I could say that's equal to 16 over 24. So cross multiply from here. Right? Since I'm going to have to distribute, I'm going to go ahead and write this out as 16 times 9 plus x. And then on this side, I'll just have 24x. So if I distribute over here, 16 times 9 is 144. Thank you. And then 16 times x is just 16x. Then I will move my 16x over to the right side, and I'll get 144 equals 8x. Divide both sides by 8. And that gives us 18.
Right.
So whenever we have a triangle within a triangle, we want to draw those two triangles separately. Guys, whenever I have a triangle within a triangle, I want to draw those two triangles separately and then match up corresponding pieces. Okay? The only potentially tricky part when you're drawing a larger triangle is you have to make sure you're adding different pieces to get the entire length. Okay? Questions? All right, you guys try number 4 then.
Make it look.
Yeah, that's that.
Geometry?
That's my theory that most teachers that fail at. Like, maybe. I don't know. Not every national says their favorite subject. What do you think? Well, I mean, okay.
Yeah.
Most of them their favorite.
No. Come back here.
I was reading that board. I was reading that board. The dry erase board was made you look. Hey.
The short explanation of calculus is that it's the math behind
No.
motion.
That's not the plan.
Yeah,
Oh,
what's the
yeah.
math behind
Oh, yeah.
calculus? Yeah.
I'm fine. I'm great. Huh? Another question.
He does show me that.
What?
Unless listen, and I almost fight for it. So I did it. I've heard this before. My mom teaches boys.
What's going on?
I told you you're music teachers. How many times
You
you
want to
go
like that gun?
care? Since I was like this big. It's nothing new. It's what, like 5th grade?
I think so.
Seth, did you hear
So for this one, if I draw my two triangles separately, I would end up with a proportion like this. 30 over 40 equals 32 over 32 plus x. Okay, so for problems like this, draw the triangles separately so that you can see which sides correspond. Right? So we should end up with something like this. And then when we cross multiply, I believe we would get 32 over 3, which would be 10.667. All right, no homework.